Hello, everyone, and welcome to our video presentation of the Miniature Animal Health Status Tracker, or is referred to as the MAST in this presentation. We are Team 23070, sponsored by Micro Entities Worldwide, which is run by Daniel O'Connor and Ben Blem. Our mentor is Elmer Grubbs. On the next slide, I'll get into introducing our team. My name's Allie Baker. I'm the procurement lead and an SIE major. Kaylee is our team lead and also an SIE major. Bryce and Jake are ECE, and lastly, Zachary is our optics guy. Now for the problem description, most people with pets or animals care about their well-being and whereabouts. However, current animal trackers on the market are expensive and bulky. There's currently no generic, small, disposable inter-animal tracker available to the general public. Our objectives are as follows. We want to build a cheap, disposable, and small device that can track an animal's location, determine velocity and movement from the GPS, and lastly, monitor heart rate. For physical attributes, we want it to be durable, reliable, and weatherproof. We also want it to be a universal device that does not bother the animal. So the picture on the right is a high-level design of the MAST to give you a better understanding of what we are building.
Here we have the design of the mast. To the left, you can see the mast enclosed with the casing and the top is missing. And then to the right, you have the mast fully enclosed with the top. We also have kept in mind the Animal Welfare Act, as that is the only federal law regarding animal testing. Next, I am going to go over the approach to the problem, which was mainly consisting of researching different sensors and casing options and, of course, adhesives. We began testing and came across a few issues. We mitigated the issues by ordering replacement parts or asking for help. We are documenting our work and preparing for design day. Here, we also have some of the major system requirements. Of course, the mast has to measure the position to an accuracy of 10 meters and measure the velocity to an accuracy of 5 meters per second and the heart rate to an accuracy of 10 beats per minute. The mast also shall weigh less than 2 ounces. Here are some size requirements for the mast, and it also needs to run on a battery life for at least 1 week. Last but not least, here are some of the other system requirements that are very crucial to our project. The most important one is definitely being able to withstand the normal wear and tear that an animal would experience in or outdoors, as that is the basis of our entire project.
From our preliminary design, there has been some notable changes that have been made in response to testing and analysis. Initially, the design was to be a patch enclosed in an ABS filament casing and attached to the animal with some sort of adhesive. This design was abandoned due to there not being any suitable adhesives that were strong and durable enough yet didn't leave residue on the animal, which does not comply with the Animal Welfare Act. For the current design, the device would be a patch in an FPLA filament casing, which is a more flexible alternative to ABS, and will be attached to the animal's collar via Velcro. Here we have a 3D drawing of the device in its entirety, as well as the schematics of the device's hardware. As can be seen, the device is double layered, with the picture on the left containing the microcontroller ETGM336H GPS module, and the bottom side of the PCB shown on the right, containing the integrated circuit for the SIM7600 LTE module, which is responsible for the wireless communication with your phone. Here we have the 3D images of the PCB. On the top left, we have the top side, and on the bottom right, we have the bottom side. Next, we have the requirement verification table. All of the design performance requirements, such as the weight, size, and lifetime requirements, have passed. Similarly, the durability requirements have passed as well. The accuracy of the GPS passed when tested outdoors and failed while indoors. This was expected as the antenna used was optimized for smaller size rather than performance. The velocity measurement accuracy passed all testing conditions, and the heart rate sensor output was also within acceptable margins, with the largest error being 11%. The device did not pass the cost requirement, with it costing about 50% over the goal, and it passed the measurability requirement, with it being able to measure heart rate through the animal's fur. Finally, while it reached goal, the mast was not successful in communicating data wirelessly to a cellular device.
Some basic results here. We have the pictures of the mast attached to both Kaylee's dog and Allie's cat. On the right here, you can see that there is a measurement for the heart rate over time, changing for Kaylee's dog. And then at the bottom of the screen, we show some of our GPS results done outdoors at light, medium, and high cover. Our goal is to be within a 10-meter average of our actual position, and that comes out to about 10 meters. So we achieve that goal. Moving forward, something that we are going to be delivering to the sponsor, obviously, will be our technical data package within the final report. This video for design day, as well as our poster, the integrated status review, which we have already done, final acceptance review pending, going to be doing on Thursday, and then final analysis and recommendations. Just basically what we would recommend they do moving forward, and then one assembled mast, maybe more. Demonstrations. So a good demonstration we will be doing at design day would be a person with a phone stands far away from the dog, far away is relative, with the Mahst tracker attached to the dog, show that the phone receives accurate GPS coordinates and heart rate every minute, and then we would have the dog run and observe the heart rate go up and the coordinates changing.
Over the course of the year, our team has had a lot of important takeaways that come in the form of surprises, lessons learned, and problems overcame. The biggest thing we took away from this was that we have to better prepare ourselves for different scenarios. We need to be able to order things earlier so they get to us much sooner. We need to have multiple options for mitigating risks and issues, and we need to make sure we're keeping all the standards in mind. Regarding getting our PCB custom design, we found that working with international companies or individuals will add a significant amount of time to the process. However, we also found that outsourcing, like we did with Fiverr, is an extremely helpful tool to increase efficiency of a project and make up for shortcoming with overall group skills. We were only really able to test the Mahst on 2 animals, Allie's cat and Kaylee's dog, up to their own discretion. However, at the beginning of the year, we were more hopeful in testing more animals such as a horse or a cow, or really any other animals that don't typically wear collars. One of the biggest issues that we ran into had to do with waiting on purchases made to be delivered from out of country, including a time difference between us and the international partners, making it much more difficult to communicate with them. And finally, as mentioned earlier, we really had to make sure we were abiding by the Animal Welfare Act, making sure that we weren't harming any animals at any step in this process. All in all, we are on track to have our completed Mahst, or at least a prototype that obtained actual results. While we have spent quite a bit of money on the PCBs and outsourcing, we were still left with around $1,500. If this project were to be continued, some tips and tricks that we have for the next team would be to mass produce a finalized PCB in order to make the process a lot cheaper. We would also advise to design and build a custom heart rate sensor, as the ones available on the market can sometimes have a difficult time measuring an animal through their skin or even fur. Overall, there are many ways that we weren't able to find to make this product even smaller. And finally, a stretch goal of ours that we weren't able to complete was to build an Android app that you can track your animals' information. And finally, we would like to thank our wonderful mentor, Elmer Grubbs, for his support and guidance through this year. Our mentors, Daniel and Ben, thank you for your encouragement and your constructive criticism through this entire process. And lastly, thank you to any of our judges who sat in during our various presentations and provided us with new ideas and suggestions to improve our project. Thank you so much for watching.